Vector and scalar projection tell us how much one vector points in the direction of another. Scalar projection just gives us a scalar, how much in magnitude does one vector point in the direction of another, and vector projection, which is what we'll do today, tells you this in a vector form. So there's a direction and a magnitude associated with it. For this problem here, we have A in red and B in yellow, and you'll notice that I've lined up their tails so that they're both originating at the same spot. Here I picked the origin in 3D space just for convenience, but it doesn't really matter where, and I want to know how much does A line up, or how much does A point in the direction of B. In order to do this visually, we can see something like this, where we draw a perpendicular from somewhere along the yellow vector up until the head of the red vector, and then this blue is what we're looking for. This blue vector is the projection of A onto B. And we have a formula for this, which looks like this. And notice how this vector proj A onto B is going to be in the direction of B. Look at the fraction. The dot product is a scalar, magnitude squared is a scalar, so that fraction up front is a scalar that we are just multiplying the vector B by. So here we get a vector that's shorter than B. It could actually go the opposite direction. It could have a negative in there, and it could be longer than B. And so to calculate this, we just look at the numerator. That's the dot product, the sum product of the components of A and B. The denominator is the magnitude squared. This is also equivalent to B dot B. So you may see that in other formulas. So our fraction that we're going to multiply B by is 34 over 120, which we can reduce and multiply throughout. And the components of the blue vector there are 17 over 30, 17 over 6, and 17 over 15. This is the vector that tells us how much A points in the direction of B. We could do the same thing for B in the direction of A, and it would look like the very similar formula. Just switch your variables around, and this is what you would get. Make sure to like and subscribe and let me know what you want to learn next.